Alright, so we are going to be starting today to talk about the periodic table and the periodic law. So when we're talking about the periodic table, we're talking about this, and you're already familiar with this. We've already been using this in class. So none of this should necessarily look new or different to you. Periodic tables can take a lot of different forms, so we are going to be talking about some general things that you can see in regards to the periodic table. As we go through this information from the periodic table, keep in mind these essential questions. We want to know, how can we organize all of the different elements? How can the periodic table help us organize our chemistry knowledge? What can we predict about elements based on their classification as well as their location on the periodic table? So, before we get started, let's talk exactly about what does the word periodic mean. So, the word periodic means basically that something happens or repeats at regular intervals. We can even think of it as cyclic, in other words, happening in a cycle. So some examples of other things that are periodic include the phases of the moon, the seasons, and tides. All of these happen within a regular cycle, in other words, that we can actually make predictions based on. Turn up my volume here a little bit because I do have some sound stuff. So let's take a look at this video clip here that talks about the historical development of the periodic table, just to get us introduced.
The first part of the puzzle was to find patterns among the elements and arrange them in a logical way. In 1864, a scientist named John Newland stated the periodic law.
Science rules.
When elements are arranged in order of increasing atomic mass, chemical and physical properties form patterns that repeat at regular intervals.
In 1872, Dmitry Mendeleev organized the known elements into the first usable periodic table.
It works like this. Elements are listed from left to right in order of increasing atomic mass relative to hydrogen.
But Mendeleev breaks them into a new row when chemical properties repeat.
Like sodium and potassium, for instance.
Yeah, they have similar physical and chemical properties, so they belong to a vertical group of similar elements.
And since the properties repeat periodically, we call this the periodic table.
Mendeleev's table had gaps in it, and he predicted that these were unknown elements. One of these elements he called ecosilicon. So when elements like germanium, which follow silicon, were discovered and matched the properties Mendeleev predicted, he became famous. Mendeleev had found patterns among the elements, but at the time, nobody could explain the big picture.
Okay, so let's take a look at how the periodic table was developed. And it actually kind of mirrors the development of the atomic model that we looked at earlier this semester. Very much like the atomic model, the periodic table wasn't done just by one person. It was actually done by many scientists. One of the first scientists to take a look at trying to organize the elements was Dobryner in 1829. He tried to arrange the elements in groups of 3. Now, you have to remember that at the time, the only atomic model that we had was Dalton's atomic theory. So while he tried to actually organize them, it didn't work very well based on how he tried to do that. But he was really the first one who attempted to look at the periodic table. Then we have John Newland in 1864. What he did was he found that when we arranged the elements according to their mass, now at this point we knew each element had its own specific mass, every 8th element was similar in physical and chemical properties. What he did was he related this to a musical scale, because if you're familiar with music at all, when you play a scale, the first note and the last note are actually the same note. They're the same letter designation of the note. So they're just what we call an octave apart. So for this reason, these were actually called Newland's octaves. After Newland came the man who was mentioned in the video, Dmitri Mendeleev. He is known as the father of the modern periodic table. In fact, he is so revered with his creation of the periodic table that he actually has an element named after him. Now, Mendeleev worked at the same time as a German chemist named Lothar Meyer. Both of these men demonstrated a connection between the atomic mass and the properties of the elements. But history remembers Mendeleev more. And the question kind of becomes why? Why is Mendeleev remembered but not Lothar Meyer if they both came up with the same idea? Shouldn't they receive equal credit? Well, this kind of goes back to what we talked about with the scientific method. The very last step of the scientific method is that you have to publish your information. And because Mendeleev published his information first, he actually received much more credit than Lothar Meyer did. It was very easy for someone to come in afterwards and say, oh yeah, I came up with the exact same thing, when someone else took that risk to put the information out there first and take the chance of being wrong. In fact, Mendeleev is so revered in his home country of Russia. If you go to St. Peter's Square, it used to be called Red Square during the Soviet era, in St. Petersburg, Russia, they actually have a replica of his original periodic table on the wall. Mendeleev was actually also incorporated into the opening ceremonies of the Sochi Olympics this year as well. One thing you'll notice, though, the giant wall periodic table, this area in Russia is very much almost like the National Mall here in the United States. It is a place where people come to visit and really reflect on the nation's history and the great things that the country has done. But one of the things that's on this periodic table, you'll notice here, those two squares are blanks. So why are there blanks on Mendeleev's periodic table?
In 1869, the Russian chemist Dmitri Mendeleev organized the 60 elements known at the time into a table. He first arranged the elements by atomic mass, and then he placed those with similar chemical properties in columns. He called this the periodic table of elements because elements with similar chemical properties appeared at regular intervals. Mendeleev was so convinced that the elements occurred periodically that he left a few empty spaces in the table for elements that were unknown at the time. Years later, the elements were discovered as he predicted.
Okay, so the reason why... I have another video clip, sorry. I don't have that one in my notes. Here we go.
Thoughts. He constructed a card for each element. On each card, he wrote the name of the element, its atomic weight, its typical properties, and its similarities to other elements. He then laid the cards out like a game of solitaire and began arranging them over and over, searching for patterns. Then came the moment of discovery. Before him was something extraordinary. The elements fell into 7 vertical groupings. Each periodic grouping had members that resembled one another, both chemically and physically. Mendeleev had discovered the periodic table of the elements, a map showing how all the elements related to one another. A map so precise that Mendeleev believed he could also use it to predict the existence and properties of 3 elements no one had yet discovered. One would be like boron, he said, one like aluminum, and one like silicon. Eventually, the elements were discovered, and Mendeleev was proven right.
There was actually a little bit of controversy because a German chemist named Lothar Meyer had come up with roughly the same idea, but Meyer didn't quite have as much courage. So that's actually an interesting thing. Here is the there were hints already before, but he doesn't make a prediction. But Mendeleev does. So here we see the power of a risky prediction in having people accept a theory. There's nothing more powerful than making a prediction that's not obvious
And then have it come true.
and have it come true. The periodic table is our icon, and that's what we associate with chemistry. You go into any chemistry room, you see it.
Why is the periodic table of elements significant? It forever changed the way that everyone would learn and understand the elements. The periodic table of elements is to chemistry as notes of music are to a Beethoven sonata. In honor of Mendeleev, his name is now literally attached to the periodic table. The element 101 was named after him. It's called Mendeleevium.
It's not only chemists who like the periodic table. I fear you carry one around.
I do carry one. Yes, sir.
Show me.
You never know. And I seem to use it a lot.
Let's see.
It's a small one.
So I'm going to give you a test. What is under nitrogen in the periodic table?
Nitrogen is 7.
Yes.
So I have to think a second.
Under
Sulfur.
nitrogen. Oh, you're wrong.
Yeah, that's why I carry
You're
it.
one up. It's phosphorus.
Oh, phosphorus.
Phosphorus is right.
Phosphorus is 15.
Yeah, you have to add 8 to that point.
See, that's why I carry it. I can't remember. So it's 7 plus 8. 15 phosphorus. Okay. There's a pattern there.
Okay. So, why did Mendeleev leave blanks? He left spaces on his table where he thought the undiscovered elements should go. Not only did he just leave spaces, but he made predictions about those elements. So when they had the properties, including, he was very close on atomic mass of them as well, and they fit his table because of that. Everyone knew that Mendeleev had finally struck upon the way that the periodic table and the elements should be arranged. He created, along with John Newlands, the original periodic law, which states that the physical and chemical properties of elements are periodic functions of their atomic mass. But now we know that this is not true. If you think of the time frame in which they were operating, we had only still Dalton's atomic theory. We had better technology, but we really hadn't advanced the atom at this point. We didn't know about protons, neutrons, and electrons. So we actually modified the periodic law. Well, what do we mean? Well, if we take a look at several elements on our current periodic table, we have several groupings of them that are not arranged by atomic mass. Like, for instance, cobalt and nickel. Cobalt actually comes before nickel, but it is a lower mass, it's a higher mass. Tellurium has a higher mass than the one after it, which is iodine. And thorium is a higher mass than protactinium, which comes after it. And also uranium has a higher mass than neptunium. So the periodic table that we have is not arranged by atomic mass, how Mendeleev first started it. So Mendeleev's table was not completely correct. What we did was we actually fixed this once we learned more about the atom, and this was because of a man named Henry Moseley.
In 1913, Henry Moseley, a physicist, suggested that it is the atomic number rather than the atomic weight that identifies an atom's properties. So he proposed a slight change in the organization of the periodic table. Instead of grouping the elements by atomic weight, he used atomic number. Remember that the atomic number is the number of protons and electrons in an atom.
Okay. So Henry Moseley is the one who actually fixed the problems. He discovered that atoms of each element had a unique atomic number. So when he arranged the elements by atomic number and not by atomic mass, the problems with Mendeleev's table were eliminated. So this led to the generation of the modern periodic law, which still holds today. It states that when elements are arranged by increasing atomic number, there is a periodic repetition of their chemical and physical properties, and this produces the simplest arrangement of our elements. So, this kind of concludes on the development of the periodic table and how it was created. The next part, what we are going to do is take a look at the actual content of the periodic table, how it is organized, what we can glean from an atom's position on the periodic table, and we're actually going to be coloring our periodic tables as well.